Good morning and good evening, friends. Welcome to goonlinetrainings.com. Welcome to Azure Databricks introduction. So this topic is very, very important if you wanted to get into data engineering role. So ADF, Azure Data Factory is nice to have topic. If you know that topic, that is well and good. But if you're preparing for the data engineering role, you have to know in depth of Azure Databricks. Lot of questions are going to be asked, especially SQL as well as in Python. Python, you need to know 30 days of Python, including simple manipulations, declaring your variables, loops, and how to do the string operations, pandas and numpy. These at least 30 days of Python you need to learn if you wanted to get into data engineering role. And SQL, in depth of SQL, you need to know, right? So without SQL knowledge, without Python basics, I'm talking about, including NumPy and Pandas and looping, declaring a variable, string operations, manipulations, all of them you should be able to do with the help of a Python. Either you use my Python videos, or you can take the videos from YouTube. That is fine. But SQL videos only, my videos need to practice. I'm telling you, SQL in depth of content I have given you. Make sure you follow them. All right. Now, daily from today, you start learning one Python video, one Python class, and parallelly, you will be able to also continue with Azure Databricks. These are the two things can go parallelly. If you know Python, that is well and good. But if you do not know Python, from today, you have to practice daily one Python video. Next 30 days, don't go more than 30 hours of Python. So that is more than sufficient for you to crack any kind of an interview. Sure. Now, let me give you the agenda for today's class. What is a big data, and who's the founder of the Databricks, and what is a data warehouse, and what is a data warehousing architecture, and what is a data lake or a delta lake or a lake house, and what is a cluster, and what is big data Hadoop, and why we are not using Hadoop, and why everybody started using, right? So Databricks today, everything I'm going to be discussing one by one. So as already we know, so IT industry is going to be storing data, right? This slide, I think you know it. When you have a small amount of data, IT industry is going to be storing the data into the files, maybe Excel file, CSV file, or a PDF file, JSON file, any file, right? So, especially this was a story then initially when the IT industry started. So, we were able to store data only in files. But slowly, after 10 years, so IT industry realized in 1970s, it is realized that so if you wanted to store the data, only files are not sufficient. So especially in 1970s, a company called IBM company and came to know that lot of issues with the files if you wanted to store large amount of data. Now that is when IBM company started inventing a concept called database management system. So how to store large amount of data. Files are not useful, especially structured data I'm talking about, means rows and columns data, right? So that is when IBM company has invented a concept called database management, and which is also called as a SQL tools or RDBMS tools. So IBM company, based on this concept, implemented or released a tool called DB2. Right, DB2 was the first RDBMS tool, database 2000. Then after that, Oracle company has given Oracle. Then Microsoft company has given SQL Server. Right. So even though it is invented in 1970, your SQL Server is released in 1989, right? I think Oracle in 1981, right? So DB2, as soon as they released database management, the concept, immediately based on that, so they have released DB2. But even though DB2 was initial RDBMS software, but today many people are using either Oracle or Microsoft SQL Server. First position, second position, So it is going to be taken. The later, the third and the fourth, you have DB2, PostgreSQL, and lot of other SQL, right? So when you wanted to store this much of a data, then GBs of data especially, we are going to be using RDBMS. Now here also we're talking about structured data. In this case also we were talking about structured data. 1960s to 1970s is the journey, 10 years of gap. After that slowly the data started increasing. So as I told you, if you have 500 GB of data every month, right? So 12 months of data, think about Amazon company, it will become 6000 GB of data, 1 year data, which is equivalent to approximately 6 terabytes of data. Slowly your data is started increasing. But during 1970s, do you think that every month we are getting 500 GB of data during that time? Answer is no. So every month getting 550 MB data, 100 MB of data was difficulty because many businesses are not using computerization. Nothing is computerized at that time, right? Very few companies, a few people are using. That is one thing. Second thing, hardware was very, very costly. So buying a hardware for a business was very, very difficult and costly that time. People unaware about the software implementation inside the businesses, right? So now we're talking about terabytes of data. That time getting a terabytes of data very, very difficult. If you'd see, when you have a large amount of data, so this concept got released. When you have a terabytes of data, uh, the IBM company thought it is sufficient, but they have realized we cannot run with only RDBMS. So the next concept took 20 years of time, 70s to 90, 20 years of time they took to invent data warehousing. Data warehouse is also one more concept to store large amount of data. To store large amount of data. Why IT industry not focusing on storing data initially? Because hardware was was not supporting. 20 years back, if you see the hardware capacity, maximum 10 GB hard disks or 20 GB hard disk, or maximum you have 30 GB hard disk, right? In year 2000, the hardware also slowly getting increased. I remember in my company, first company in Bangalore in year 99 2000, we bought a laptop for my boss. We paid 2.5 lakhs. IBM ThinkPad we got it. That was costing around 2.5 lakhs, and with 128 MB of RAM and 40 GB or 20 GB hard disk. See, so hardware also not ready. In 2000, I'm talking about. If you wanted to buy one more hard disk, then 50,000 rupees more you need to put. So 28 GB, 20 GB, or 40 GB, 40 GB hard disk we used to get it. So hardware also so much costly that time, and people are not worried about storing the data. Every time processing the data, companies also does not have the data because many companies are not completely using computers, right? Whether you take banking industry or when you take insurance industry, people who are slowly are using the computers inside their businesses. Clear? So that was the reason we do not have a big amount of data getting created. So it took 1970s to 1990s. They were not realizing, but again the IT industry realized we need to have one more software, data warehousing. So that means, so when you have a data warehousing, you can store structured data. What is data warehouse in simple layman terminology? Large hardware you need to buy. Inside that, you need to install again SQL software. SQL means maybe Oracle, maybe SQL Server, any software you can install. So this is what is called data warehouse. That's it. So, but what is the advantage? The advantage will be you can store terabytes of data, right? That is the advantage. So data warehousing is implemented to store large amount of data. If you wanted to store large amount of data, what is the size I'm talking about? Terabytes. 20 years back, average data warehousing size was only 14 terabytes, not more than that. If we have a 20, 30 terabytes, it will fail. So average data warehouse size I was talking about 20 years back, when they implemented 14 terabytes only. Maximum I could see 2 terabytes of data warehouse or 5 terabytes of data warehouse, like that. Today, the data warehouse has gone up to 100 terabyte. Today, I'm talking about today, the average data warehouse it can take up to 100 terabytes of data. Clear? So data warehouse is a single bigger machine. Because of modern hardware, modern technology, now single data warehouse today capable of taking 100 terabyte of data. But 1990s, I'm talking about that time, 1991 or year 2000 or even 2005, 6, 10. Also, we can store only one data warehouse, means 14 maximum, that is, or people may go up to 10 terabytes. Then if this is full, they will be going for one more data warehouse. So couple of data warehousing machines you can have it. This was a story in year 1990s to 20 years. But after that, what is happened? Right? 1960s, I have discussed clearly. 1970s, I have discussed. 1990. But immediately, slowly, lot of changes are started coming in. Internet is introduced worldwide. Social media slowly getting introduced. Hardware becomes so cheaper, and smartphones and everything slowly getting launched, and lot of IoT devices, web application launched, and a lot of computizations. A lot of companies, businesses are started using banking, insurance. A lot of people are using computerization in their companies. Slowly, data started size getting increased, right? So when the data size is getting increased in early 2000, Google company was experiencing it, because Google company launched Google search in 1990s, right? So in early 2000, Google company experiencing getting a large amount of data, but IT industry does not ready it. So Google company in 2003, they have given a special concept. So we are now getting a big data, right? Now problem earlier, no company thought we will get so much of a data. So that was the initial IT companies, thinking, right? Everybody thinking, why we need to have so much of data? Even Microsoft, Bill Gates says that we do not need more data to be stored in our computers. If you're buying a hard disk, that is of no use. Even Bill Gates was used to say that time. So because people were not focusing on storing the data, every time they were only focusing on the languages, how to compute the data. Compute means, so we're talking about the processing of the data. So languages were so popular first initial time, 60, 70, 80, 90. You have C++, Java, .NET, Python. Only many languages came into existence. They were not focusing on on data storages, right? So that was the reason we got right, from files to databases to data warehouse. It was taking a lot of time. But if you see languages, every 5 years, every 2 years, there is a language. So you can understand, IT company was focusing on processing initially. They were not focusing on how to store data. But in year 2000, when the Google company said, hey folks, we need to stop only doing R&Ds on languages on Java, Python, .NET, only languages, C++. No, we need to stop the processing, and we need to ensure that we need to store large amount of data. When the big data started coming in, so big data means not only structured data. Structured data means these computers can handle, if you see carefully. So up to terabytes of data, files, small amount of data it can handle. This guy can handle it. Even this guy also can handle it. So structured data, there was no problem. But in the big data, we were getting not only structured data, but also semi-structured data and unstructured data. Today, early and entire globe has, remember, today, entire globe has 20% structured data, remaining 80% only unstructured data, semi-structured data. Remember, right? So your AI is not going to work on more and more on this data. Your AI most of the time is going to be working on this. Remember, Your AI is not going to work on your structured data, right? So when you have a semi-structured data, unstructured data, AI needs only this much of a data. So AI became so popular when you have a big data environment is started. When AI started before here, somewhere here, 1950s, your AI and machine learning was introduced 1950s, right? But even though it was introduced, it does not have so much of a data. So AI completely stuck. It does not have so much of a data to practice, to create a good models. But slowly, the data storing industry, you know, uh, uh, it is getting prepared for the next, what do you say, a next level data to store. But slowly, even 1950s onwards, you have, AIM and AI and ML is also there. But AIML started a new journey after year 2000 only, because it needs so much of a raw data. The raw data, especially we're talking about semi-structured data, unstructured data, we have it here. So on this data, you can work with the A and ML models, you can do a lot of predictions, right? So on the structured data, even though we have lot many things in this, so much more time what we were doing, we were only creating a data analytics, or you can say business intelligence was running. That means normal Power BI reports, all of them can run on this. Clear? You will be able to get the data. When you have a structured data is not suitable for the AI ML to run. Most of the time, you can use it, but most of AI applications today are running on the semi-structured, unstructured data, and it needs so much of a data. When the big data environment started, so every people thought that they wanted to have only, they wanted to have that, they are not ready with the storing data. So this paper has been taken by a company called Apache, software company in year 2003, Apache Software Foundation. And to store any kind of a data, now we need to have a software. Initially, you were only storing structured data, but beyond that, you do not have anything. So, year 2000, big data problem is how to store the data and where to store the data and how to process the data. These are the big data problems. First, how to store, then where to store and how to process. We're not talking about a small amount of data, we're talking about a petabyte, zettabyte, yottabyte of data. This kind of a data, especially structured, unstructured, semi-structured data as well, right? So before 2000, the IT companies completely ignoring unstructured data or semi-structured data. If you see my diagram, data warehouse completely focusing on structured data. That means they did not get any video files, audio files. Unstructured data means, semi-structured data means JSON files. We're talking about your charts, maybe your XML files. Structured data means we were ready. SQL tables are there, Excel tables are there. So you may have CSV files are there. So somewhat IT industry is ready with the structured data, not ready with the semi-structured, unstructured data. In year 2003, when the Google company said this kind of a data we are getting it, how to store data and where to store the data, how to process the data, these people have released a paper in 2003. These are the characteristic of big data. This is how big data looks like. This is how big data will have a problems. This is how we need to write it. So lot of characteristic about big data they have described in their white paper that has been released into the market. So using this paper, which is out by Google company only given the big data naming in 2003, right? So you can understand big data era suddenly started early 2000, but 2003 everybody is talking about big data. Now after that, all this data became a small data. Now, only two. Small data means this is small data, and big data means this is a big data. Now everybody started focusing on this. Apache company released a software called Apache Hadoop in 2006. Now immediately there was an issue here because of that. Apache Spark in 2009, this company has released. Now today, to store big amount of data, big data, we have 1,000+ applications. Not only Apache Hadoop or Apache Spark, we have MongoDB, Amazon EMR, we have Google BigQuery. You see Amazon, Microsoft HD Insight. Lot many tools are available worldwide today. If you wanted to store big data, you can have 1,000+ tools, right? Not only Apache Hadoop or Apache Spark, you have thousands of tools. But if you wanted to work with the machine learning AI, so you need to understand this much of this kind of a data is more useful. And here we are going to be doing more data analytics. Okay, structured data where your business intelligence will be used. But even though we use AI was very less on this data. AI can use more of unstructured data, semi-structured data heavily, even though AI is going to be using structured data. But remember, AI will get more data today from this too. Do you understand? So where you can store the data means either you can use for this, you can use it for this. So when you have a less amount of data, small amount of data, up to terabytes data means this was a story, right? But today, after year 2000, so even though 1950s you have AI, but till 2000 AI was also sleeping. So 2000, onwards only AI slowly started increasing because AI needs more and more data, especially this kind of a data AI will take a lot. So now AI is booming because of we have solved two problems. What are they? We can store unlimited data today with the help of these softwares. We can also process unlimited data today. These problems have been solved by big data, especially from Apache Hadoop and Apache Spark. All right. Now, let us understand what is a big data. Big data means, as I told you, it has to have three characteristics. According to IBM company, company has given, a abbreviation. Big data means it has to have three V's. One is called volume of data, large size data. So one is a petabyte, zettabyte, yottabyte of data the companies are going to be having. The second V, volume is one thing. Second V, I'm talking about. Second V, variety of data. So companies are ready to store structured data, either SQL or you can say data warehouse. What is the data warehouse? As I told you, data warehouse is also SQL. But if you have large hardware, then it will become a Oracle data warehouse. If I take my laptop, this is my laptop. In my laptop, I have a 4 GB of RAM, one i3 processor. I have a 512 GB disk. So, what is the maximum data I can store it here? You tell me, even though I install SQL software here. So, what is the maximum data I can put it? 512, because hard disk capacity is that. But another side, you buy very bigger computer with 100 terabyte of disk. Okay, this is a disk size I'm talking about. Then thousands GB of RAM, and you have very bigger i5 processor, let us say 100 processors running. So this is also one more computer. You install same SQL here. SQL means Oracle, everything. Because you have so much of a disk space, same SQL is going to be running as a data warehousing machine. So here we simply say I have installed SQL. Here also you say I have installed SQL server, but this is SQL server data warehousing machine, right? Both of them are SQL only. Maybe SQL Server, maybe Oracle, maybe Netezza, maybe database, 2000, this one and that one. End of the day, what you need to understand is that large hardware you are going to be having as part of your data warehouse. What kind of a data are going to be storing? Again, structured data only. So we were not dealing with the unstructured data and semi-structured data here as well, because people does not use social media that time, right? The next one I'm talking about unstructured data. So binary data, it is also called as binary, means ones and zeros. Any image, any photo, any audio, any video, anything you have it, it will be converted into ones and zeros in the computer. It is going to be saved. Clear? So this kind of a data is called as a binary data, or people are going to be calling as unstructured data, right? Your IoT data, sensors data, sometimes the textual data also, right? If you take one notepad, if I'm going to be writing some data here, it does not have any shape. Simply, you'll have paragraphs, right? If you take a paragraph, what kind of data it is? It is also unstructured data. Even though it is there in the file data may be structured, and the file data may be also unstructured. So when you have a paragraph by paragraphs, so this kind of data is called as unstructured data. Structured data also you can have. So notepads always need not be structured. It can also be unstructured data. That is what you got to understand. For example, sometimes I may have employee ID, employee name, employee salary. So this is a structured data in the notepad I'm talking about. Clear? So notepad also can have structured data, unstructured data. So I wanted to write paragraphs by paragraph. What will happen? It will become unstructured data. So that kind of a data I would like to store. Now, velocity is going to be playing very, very important. Velocity means speed in which you are getting the data. Now, if I get a 500 GB of data every month, so month data I'm talking about. So into 12 months data, it will become 6,000 GB of data 1 year, which is equivalent to 6 terabytes 1 year. Okay. It is 1 year data. Slowly it is coming. So if you wanted to get 60 terabytes of data, you have to wait for 10 years. So what is that? So what is the time I need to wait? 10 years, I will get 60 terabytes of data. This is the data I'm getting it. Now tell me, if one data warehouse is capable of handling, let us say, 100 terabyte of data. Okay. So if you are getting 500 GB at every month, so it will take a minimum 10 years to use one single data warehouse. But think about, every day you are getting 2 terabytes of data, or every month you're getting 2 terabytes of data, right? So within 1 year, it will become what? It will become 12 months, means it will be 24 terabytes, right? 24 terabytes within 1 year of data. But within 4 or 5 years, within 4 years, you will have, what is the data? Approximately 100 terabyte within 4 years. So this is one more use case. This is one more use case I have spoken about. This is one more use case I am talking about. See, speed. So 2 terabytes of data per month, and 500 GB per month. Now let me take one more use case. So every day you are getting, let us say, 30, or every month you're going to be getting 30 terabyte of data per month. Now within 3 months, you are going to be getting this much of a data within 3 months. So speed is so much. Okay. So daily you may be getting 1 GB, 2 GB of data. Daily you may be getting some data. But here, 1 month data, if you see, if you wanted to store this data into the data, in your data warehousing maximum capacity is 100. So within 3 months, you have to buy one more data warehouse. Within 3 months, you have to buy one more data warehouse. Speed in which you are getting. So every month the data is this, every month data, every day, every month data will be like this. When you have now talking about the fourth scenario, now every day you're getting, let us say, 1 petabyte of data. 1 petabyte is equivalent to, let us say, 1,000 terabyte of data. If you're getting 1 petabyte of data every day or every month, so what will happen? Do you think that your data warehousing system can handle it? Because speed is so much. Now the data you're getting in bigger speed, sizes are getting increased, right? Now every second you're getting only 5 MB of data. Here every second you're getting GBs of data. Here every second you may be getting some amount of data. Here every second you're getting terabytes of data. So the sizes are going to increase. So slowly your existing you know store, or existing to storage will be full within 3 days or 3 months. you cannot go in for data warehousing, even though I'm talking about only structured data. So because of the speed, your data warehousing also will fail. Clear? So data warehousing means what? It is a large hardware with the SQL you need to install. So how many machines we are going to be having? Only one machine. So where are the data warehousing machines and everything? All of them will be available in your data centers. When you go to any data centers, IT companies are going to be maintaining lot many data centers worldwide. So it may be one bigger data warehousing machine. This may be one bigger data warehousing machine. So all the data warehousing machines, bigger machines, but today also it can take 100 terabyte of data. And what is the problem with this? It can only take structured data, and if you have 10 years or 20 years of that time, I can easily run. So if you're getting every month 500 GB of data, so I have done the calculations. 1 year data, 12 months data will be 6 terabytes of data. So 10, 20 years, it may take 100 terabytes of data. So if you are having this kind of a size, I can implement my data warehousing even today. It will take 10, 20 years because I was only getting structured data, right? So all the data warehousing machines, either you maintain in your company. So how to maintain the data warehousing machine? You need to buy bigger hardware and install SQL, Oracle software, SQL software, so that it is going to be your data warehousing. You can maintain the data warehousing in on-prem. On-prem means what? It is going to be your own data warehouse. It may take up to, let us say, 100 terabyte of data today. So what kind of data it can take? Structured data. How many machines? Only one machine. Data warehouse means single machine only, right? So already you know, but we're talking about big data. You cannot store speed in which the data comes. This is one way. And a variety of data, structured, unstructured, semi-structured data. This is one way. Volume is also there. So three is are called as a big data. When you have so speed in which you're getting the data, even data warehouse cannot, store your data. If data warehouse cannot store the data, you need to completely jump into or dump into your big data environment. Clear? Now the next one comes how big data is going to store unlimited data, right? Because big data means you need to have hardware, right? So how big data is going to be storing? So let me give you softwares. We know softwares, we know Apache Hadoop you need to install, Apache Spark you need to install. Those are softwares. Here, what is a software? SQL. Here's SQL software. Here, software is Excel software, CSV file. Software we know, but hardware wise, how it is going to be storing? Let me tell you. So one thing, what you can do, you will be able to go and two things you need to understand. One is horizontally you can, and vertically you will be able to go. So what is the meaning of this? I can buy one computer. I can buy one computer. This is my computer, right? So in my computer, I may have some capacity. For example, I may get 10 terabyte of disk. Bigger hardware I bought it, and I'm having 100 GB of RAM, and I'm having, let us say, 120 i3 processors running. Okay, so this is my bigger hardware. So after that, what I'm going to be doing, I because 10 terabyte of hard disk full, it is full. So what I do, I add I add 10 more, 10 terabyte hard disk. And 100 GB of RAM is also not sufficient. I may take, let us say, another 50 GB of RAM. I'm going to be adding to the existing hardware. You assume that your motherboard and everything can take it. And 120 processor running, another 40 i3 processors also I'm able to add in this. Now it is taken because I'm getting so much of data. What I'm trying to do, I'm trying to add some more, you know, configuration to the existing hardware. Only one hardware, because so much of data I'm getting it. So now after some time also, even this is not sufficient. You're trying to add again some more configuration. Now tell me, to the existing hardware. So I would like to add 10 more data, terabytes. I want to add 10, 20 GB of more RAM, because more and more data you're getting it, your RAM is also not sufficient. You keep on adding, keep on adding, keep on adding. So someday this also will fail, right? So you wanted to store large amount of data, whatever be the computer that you have it, to that only you're adding RAM, you're adding hard disk, you're adding motherboard, you're only doing that, you're increasing the capacity. Now tell me, one day you're getting so much of a data, that data single machine cannot handle it. That one single machine cannot handle it. So what you need to do? So people have realized it that single machine concept cannot be implemented. Data warehousing is even today single machine concept. One machine, you need to buy big hardware, install SQL, you keep on putting the data. If it is full, then stop it. But assume it can handle at least 10, 20 years of data, so that one data warehouse can handle, right? If that is at least the full, after 10 years, I can buy one more hardware. I can try to put data for next 10 years. So 20 years, I can maintain two data warehousing machines. That was okay. But data warehouse is a single machine. Remember that point. Now, I was talking about today, if you get 50 terabytes of data one day, second day 50 terabytes of data, do you think that one machine can handle it? So one machine cannot handle it. So slowly, IT companies, slowly, they have said, one computer we cannot have it, we need to have multiple computers, right? One computer. Data warehousing is a centralized, one computer can store large amount of data. But if you want to store large amount of data, one computer architecture cannot work. We need to have multiple computers, and all of them are working together, right? So this is what is called from single computer, architecture, single computer architecture, to slowly we have, come to cluster architecture. Cluster means, if you want to store big data, even though you buy very big computer, even though you buy very big computer, so one computer is not sufficient. You need to buy multiple computers. So this is machine number one, computer number one. Okay, this is a machine number two. Like that, lot many machines you are going to be buying it today, and you try to store your data. So big data cannot be stored in a single machines. Big data is going to be stored in the cluster. You have cluster with today thousands of machines, 2,000 machines, 4,000 machines, 5,000 machines, 10,000 machines are working together. So slowly, data earlier was stored in the single computer, that is a centralized storage. When the big data started, the centralized storage is not sufficient. So big data introduced decentralized storage, right? All the data cannot be stored in a single machine. Now all the data, for example, today, if you have, let us say, 100 GB of data, you are getting it here. So if you're getting, let me say, 100 GB of data, you're getting it here. All 100 GB data will go to a single machine. Tomorrow, if you have 2000 GBs of data, also it will go to single machine. Only one machine can handle. But here, if you take, let us say, this is 100 GB of data. If you have a four machine, the data gets distributed. Clear? So, four machines are going to be distributing 25 GB of data here, 25 GB of data here, 25 GB of data here, and a 25 GB of data here. So, big data architecture is decentralized architecture. This is a data warehousing architecture is centralized architecture. Remember, all the data you can get, and you will be able to store. We're talking about up to terabytes of data. You can manage all the data. You may be having data in multiple machines. So all the data you can bring it, you can clean it and store them in the data warehousing environment. Now after that, what you do, you're going to be processing. So data warehousing is a centralized data architecture, but big data cannot be stored in a bigger machine, because you don't get a bigger machine. Simple example, I wanted to wash my clothes. So 5 kg washing machine is available, or 10 kg I can buy it. I am running a hostel. Family purpose, I can use either 5 kg, 10 kg washing machine is sufficient. I am running a hostel with, let us say, 100 people. Do you think that very big washing machine you can get it? 100 people, you go and check what is the hardware capacity. Maybe for house, domestic purpose, you may use 10 kg washing machine. But if you wanted to wash 100 people clothes or 200 people clothes, do you think that you will have very bigger machines? No, you may get 25 kg or 50 kg or 30 kg washing machine. That is the bigger machine you can get it. So if you have 100 people laundry to be done, do you think that you can buy very bigger machine? Or instead of that, what you do, you are going to be buying small machines, maybe 10 kg machine, maybe 5 kg machine, maybe 15 kg machine, maybe 20 kg machine. Like that, you are going to be buying and keeping 4 or 5 machines in the hostel, so that tomorrow 100 people are there, they can use 4 machines. Tomorrow you are doing a very good business. What will happen? You are having 200 people, 300 people. So what is that you need to do? Very simple. Buy some more washing machines. You need not do any changes to the existing washing machines. Already 4 machines are there. It can handle 100 people data. So 3 times, 4 times they can use it. Morning 6 to 10, they can go wash their clothes. Evening 6 to 10, they can go wash their clothes. 4 to 5 times it can run aramly, and you will be able to complete the process. But 100 people more came, or 200 people more came, or 500 people more came today, tomorrow, what you need to do? Nothing will change. Only buy 6 more washing machines or 10 more washing machines you need to buy. Those washing machines also need not be very high-fi washing machines. What is the meaning? You may buy 6 kg washing machines. You can buy 10 kg washing machines. You may buy 15 kg. So any configuration is fine. So what you need to understand, if you wanted to give more load, so you cannot store the data in a single computer. Big data environment is completely decentralized architecture. However, hostel, the number of people are increasing. We are not worried. We are simply buying the washing machines, so that all the washing machines have to get water connection, and soap, liquid soap, wash soap you need to supply, power supply. When you give it, it is started working, right? So big data does not require hi-fi hardware. Remember this point. It needs only commodity hardware. What is the meaning of commodity hardware? It is a cheaper hardware is also sufficient. What is the meaning? 4 GB of RAM, one laptop you have, you can put the laptop into a cluster. It can also process. For example, my laptop, I can put them in the cluster. So my laptop also can take 1 TB of data, that is a hard disk, and I have a 4 GB, 8 GB of RAM, I can put as a cluster. It can also take 1 TB of data, and it can process it, right? So 4 kg washing machine also fine, 10 kg washing machine also fine, 20 kg washing machine also fine, even small 2 kg washing machine also fine, because we are going to use 20, 30, 40 washing machines. So cluster does not require hi-fi hardware. Remember this. Cluster does not require hi-fi hardware. Now, data warehouse needs hi-fi hardware. You need to buy very high configuration, because I'm talking about 100 TB of data, a single data warehouse can handle. To that, you need to have bigger hard disk capacity, bigger RAM capacity, and you need to have a lot of other things also, hi-fi configurations you need to have. That is centralized and high configurations with with kind of architecture. But I'm talking about a cluster. Now, the other side, it is decentralized architecture. You need not have a very bigger computers. Very small computers also fine. I will give you one more example. 10, 20 people wanted to go to picnic. We have discussed. So tomorrow, all 20 of us will go to picnic. What we do? We have a bus, 20 people, very nice. And we can take all raw material. What is that you wanted to prepare? Pizza, biryani, or a burger, or I wanted to have some water bottles. Everything you can carry in the bus and go. And you're going to be cooking everything in your picnic spot. You reach by 8 o'clock morning, 9 o'clock. Everything is centralized. Everything you kept it in the bus. You go, you prepare the food. So 20 people you can easily accommodate, or even 200 people we can get everything, and we can cook the food in the centralized. So everything we're getting it and we're cooking it there. Or tomorrow, 2,000 people, 20,000 people you can manage. But do you think you have to cook for 1 crore people? You have to cook for 10 crore people. Do you think that you can get all the raw material to one place and cook it? If that is the case, you have to get the material to the bigger lorries and try to cook the data, means it will be difficulty. So what normally we do? If 1 crore people wanted to go to picnic, so instead of cooking the food in the central place, we are going to be telling them decentralization architecture. What you do? We are telling every family has to cook the food in their home. For example, you four people are coming for the picnic. You prepare the food for yourself in your, with using your stove and using your material. You cook the food and get the material to the picnic spot. Like that, even the 1 crore people are coming for the picnic, we are not getting any raw material there. We are not bringing anything, but 1 crore people are coming to the picnic on time, and they will be able to have the food there. So what is the trick here? Nothing. With your stove, small stove you have, with the stove you can cook your food. So my family also wanted to participate in that. I wanted to come there, but I will take the raw material, 4 or 5 people raw material. So we are 10 people or 4 people, we are going to be using our own stove, preparing the food, packing everything, and we are also coming there. So whether it is a 2 crore people or 10 crore people, if you follow this architecture, if you follow this architecture, anybody can easily come there, and no chaos at all. So what are we doing? We are not getting all the raw material. We are not cooking in a single place. Single place means you need to buy bigger stoves, bigger godowns, bigger water cans, bigger chicken fridges. Everything you need to have it. So that is not required at all. So decentral architecture says whatever be the stoves that we have, whatever be the fridges that we have, you only cook for 4 or 5 items. Now, even though we're talking about 100 petabyte of data, 1000 petabyte of data, one computer is not going to process anything. So even though we are getting so much of a data here, we are going to be having thousands of machines coming together. So end of the day, 1 crore people or 1 petabyte, 2 petabyte of data also comes. All the data will get distributed. Cluster will be having, cluster means not one machine. Cluster means need not be costly machine. This is what is called a cluster machine, or you can say node. Okay, it is one node. This is 1 2 3 4 5 6 7 8 9 10. It is a 10 node cluster. So what will happen? Even though you're getting 100 GB, 4 machines are enough. Tomorrow you may be getting 200 GB. These 4 machines are enough, but 2 times I'm going to be running. So morning 6 o'clock the laundry will get over. Again another 100 people can go use the laundry evening. So the same cluster I can use twice or thrice or 4 times. If it is I'm having so much of data, I may increase the cluster. So the cluster means multiple computers working together. What is the advantage? All these are small configuration hardware, need not be bigger hardware. One more advantage, even though this machine fails, is there any problem? One machine fail. For example, you and me want to come to picnic. What has happened? My stove is not working. What I can do? I can ask you to prepare my food. Help me, because we are four, you are four. So my work also I can give it to one more guy. So that guy will say, no problem, Bhaskar, you don't worry about it. I will also prepare the food for you for four people. So we can go to the picnic without any problems. If one machine is not working today in the cluster, there is no problem. Other machine can take its load and try to implement. So if there is a failure, also no problem. But if the data warehousing is ready, if one data warehousing is fails, what will happen? You need to maintain same data warehousing with the same configuration, with the same data. If this is a burnt, I need to have one more. So much of a amount you need to have it. So much of a backup plans you need to have it. It is always a costly affair. But here, one machine is not working, or two machines are not working, or three machines are not working. I'm not worried. Remaining seven machines, 4,000 machines, 50 machines are not working. Is there any problem? The 50 machines work, you can give it to other machines. Clear? So cluster is always good for big data. Big data is completely decentralized architecture. Multiple machines working together. That is one thing. All the machines need not be hi-fi hardware. It is going to be using commodity hardware. Commodity means cheaper hardware. Clear? You can have 10 kg washing machine, 5 kg washing machine. And here, the data will be distributed. It is a distributed architecture. That is third point. Fourth point will be all the machines can run parallelly. This machine can take 25 GB of data. This can make 25 GB of data. This can make 25 GB of data. It is going to be running. For example, I wanted to do summing operation. I have some 10 number, 10 and 20 here. So 30 it is going to be bringing. So I have given 5 and 6. 5 and 6, 11 it is going to be bringing. I have given 0 and 7. 7 it is going to be giving. I am giving 11 and 2. 13 it is going to be giving. So all this data 30 plus 11 plus 7 plus 13, everything I need to give a final output to the customer. So you will get intermediary output, and after that you will be able to get the final output. Okay, because 4 machines are running, not single machine. So what is the coding style here? Earlier, so normal Python or Python now within your cluster. So what is the difference between normal Python, Python or PySpark within your software? Here, the Python has to distribute the data in the cluster, and it has to get the intermediate results, and again final sum it has to produce. The normal programming is different than the programming in the cluster. Are you able to understand? For example, I'm going to be giving you 10 numbers to get the sum. So what you do? You take 10 numbers, you're going to be summing. That is a single person doing. But I'm giving those 10 numbers to, let us say, 2, 3 people. 3 people I have distributed. You take these 3 numbers and sum. You take these 3 numbers and sum. You take these 3 numbers and sum. Then afterwards, I'll be getting intermediate results, and I'm going to be doing the final output and giving it to my boss. So now, what is the biggest difference between normal coding and big data coding? Every time you need to understand, I need to distribute the data, I need to distribute the code, and I need to get the code and summarize, and the final code I need to send it. Always you need to keep this mindset. Clear? Normal Python is going to be working on a single machine, but a cluster means multiple machines. If one machine is not working, so what we need to do? So second machine has to take the that data which has been given to it. So the data you need to reload it to second machine or third machine, and you need to complete the work and try to get the data and show the final data. So did you understand clearly? So that is what is called a big data or a cluster. So cluster. So what is that? We're going to be having machines, but what software we're going to be installing? Either Hadoop need to be installed, or if not Hadoop today, so we are going to be using what? Spark today. Clear? We're not going to be doing everywhere Spark, every machine you need to install the Spark. That is what you need to understand. Hadoop or Spark. So one of them you should be able to install. Clear? So if you say, when you have a small amount of data, what we are going to be doing? We're going to be implementing in the data warehousing. Now, what is a big data? Means a commodity hardware. If you have, that is fine. It is a distributed cluster, means multiple machines working together. Parallelly, the work can run. Fault tolerant means if one machine is not working, other machine will be able to take the data of that machine and try to works. And 100 times faster, and if you install the data into the Spark, Spark is going to be using all the data into the RAM. Already we had seen one architecture, right? So initially we were talking about Hadoop. So Hadoop is big data software. Hardware is completely you need to buy it. But the big data software, first of all, we got Apache Hadoop. That's what we told you. The first software is this. It was given by Apache company for free only. You need not buy anything. Here, two things we can do. One is called storing data. The second one is called processing data. Storing means what? HDFS. The second one is called map reduce. So two algorithms, two things will be having here. HDFS means Hadoop distributed file system. It is going to be storing all the data into the disk. Processing means you need to use one language. Map reduce algorithm where Java code you need to write it, right? The first big data software is this is released in year 2006 by which company? Apache company is given Apache Software Foundation. It has released in year 2006. And Hadoop distributed file system, you can understand, it is going to be storing data into the files only. Remember, because how do you store the data? Either you store the data in a tables or in the files. In SQL, how do you store the data? Tables means SQL data I'm talking about, right? So you're going to be storing the data into the tables in SQL. So that, but how do you store the data into the Hadoop? Hadoop distributed file system. Okay, Hadoop is going to be storing the data in a file system. What do you mean by file system? File system means your Windows file system you have. So what is a file system? You go to Windows C drive, D drive, create a folder, and inside the folder you create a file, store your data. That is a Windows file system called NTFS file system. You know Windows file system, right? If somebody tells you, how do you store data in Windows? You say, Windows will have a file system. I'll go to Windows. So it may C drive or D drive. What I do? I create a new folder, go create a folder, say my data. So this is a folder. After that, how do you do? You're going to be double clicking on this data and create one file. Already my data is something is there, right? Let me go to D drive or C drive. My data already has created a folder. After that, what I do? I create a file. I'm going to be storing, let us say, employees data. Double click on this. I'm going to be having employee ID, employee name, employee salary. So how do I store the data in the my computer? Using what is called as a fi- Windows file system. Windows file system I'm going to be using. The data will be like this. Windows file system is called as files only. We are going to be creating is called as a new network. Okay, new technology file system. It was called as. But Hadoop is also storing your data where in the file systems only. Files only you're going to be storing. It is called as a Hadoop distributed file system, right? So Hadoop is also storing Windows storing data in files only. You can create only files and folders. In Hadoop also, we can create a files and folders only. It is also called as a Hadoop distributed file system. It is going to be storing the all files where? Into the disk only. But Hadoop is also storing all the data into the disk only. Hard disk means permanently it can store the data. There is no problem at all. End of the day, data has to be stored in the hard disk. So Hadoop or Windows, both of them are softwares, are going to be having different file systems. One is called it is NTFS file system, and we are using HDFS file system. Both of them are going to store the data. There is a small difference between this one and this one. Hadoop distributed means all the data will not go to one single place. It is going to be distributed. That is the meaning of this. I'll talk about it later, but it is going to be storing all the data in a single place. It is going to be distributing. Clear? But end of the day, both of them are permanently stored. So you need to know all these things clearly. So HDFS also storing the data into the disk files. And if you wanted to process the data, process means I wanted to perform the summing operation or I wanted to do any other operation. I need to write Java code. Java really complex. Really complex. It is not suitable. Uh, you know, co- it is not easy. So not everybody can use this. Because of these two things, many people stopped using this. So Hadoop completely failed. Within 2-3 years, again Apache company has released a Apache Spark. Apache is also free software. It is released in 29 by Apache Software Foundation. Now, how do we store data? So, if you take storing, and again, two things big data is going to be giving processing also. Storing will be done in the RAM, and the processing will be done using a new language called Scala. So, Java is they have removed. This is the new language they have invented. New language this is invented. It is very, very simple language, right? So what are the problems here? The problems, it was storing into the disk. Because of that, the here, even though it is there in files here, and it is slow. That is the issue. If you store any data into the disk, so how do you store? Using the files. So that we have discussed. But the problem, biggest problem in the disk, which is slow and complex. Because of slow and complex, the Hadoop stopped using by many people, and many people said we are giving large amount of data. Now Hadoop is slow. Hadoop is slow. We cannot write complex code. We cannot write complex code. Then immediately Apache Spark, instead of storing the data into the disk, they said you can store the data into the RAM. Now, don't use Java. We are going to be giving you new language, Scala. So Spark is released with the new language called Scala. Spark is completely faster. How much faster it is? It's 100 times faster. It is 100 times faster, which is going to be free. Clear? Because of that, today everybody started using Apache, but you can see Apache cannot store data permanently because it is there in the RAM. So, if you want to store the data, you have two options. Either you can go to Windows, okay? You can go to Windows and create one folder, let us say my data, and store all your files in your this one. This is permanently Windows can store where in the hard disk. You can store the data here permanently, or you can go to Hadoop also. Hadoop also you can go. Hadoop also will have what? HDFS. So here we have NTFS file system, right? So in Windows or in your computer, you can install Hadoop. Hadoop will be using HDFS file system. So we can also store the data into the files. This is also going to store the data into the hard disk. So for storing the data permanently, either you can use Windows or Linux, any operating system, you can use it. You will be able to, or Unix operating system, anything you can use it, so that you can create a file, store the data permanently. Or if you're using a Hadoop, HDFS also can store the permanently. So permanently means this can use. But if you wanted to process what we are doing, we are, instead of using MapReduce today, we are going to be using Apache Spark. Apache Spark cannot store your data. Apache Spark is completely dumping the data into the RAM, right? So maybe from here or from here, you can dump the data into the RAM and use this new language and try to process the data. The biggest problem with the Apache Spark, it cannot store your data permanently. Either you can install Hadoop and store your data in this architecture, or you can install Linux, Windows, wherever you wanted to store the data, you can also store. There is no problem at all. But in the cloud, we can also store your data into the blob, right? Or in the cloud, we can also store the data into the data lake. So anything, or you may have data in Windows file system, blob, HDFS, anywhere you can, because this is also stored in data in the disk permanently. This is also permanent data. Anything you will be able to use it. And the cloud means data lake blobs we can use, or S3 buckets we can use if it is Amazon, like that. So Apache Spark cannot store the data. Apache Spark is completely data processing engine. Apache Spark is a big data software to process large amount of data. Why Apache Spark is faster? Because it's going to be storing all the data into the where, into the RAM. So how many machines you can have depends upon the size, right? You may have two machines, three machines, 1,000 machines, 2,000 machines, 4,000 machines, 10,000 machines. Everywhere you must install Apache Spark. Apache Spark, all machines, Apache Spark need to be installed. So normally Apache, either Hadoop or Spark, cannot run in your Windows operating systems. Most of the time, we are going to be using Linux operating system. Clear? Apache Spark can run on Windows operating system, but if you want it to use efficiently, we are going to be using Linux operating system, either Ubuntu, Red Hat, right? Lot many versions we have in your Linux. For example, Windows has Windows Vista, Windows 11, Windows 7. We have many versions in Windows, right? Like that, Linux also has many versions. Linux has Ubuntu version. Linux has a Red Hat version. Lot many versions we have. So if you wanted to install Apache Spark in your computer, compulsorily you need to have what? First, either Windows or Linux. But what is the recommended? Linux operating system is recommended. So you need to install Linux. So in Linux, which one? Anyone. So Linux you need to install. So Linux what? Either you can go in for Ubuntu. Ubuntu operating system. So after that, so this software is prepared using a Java. Compulsorily, you must install a Java virtual machine, Java 11, Java 13, and after that you need to install Spark. If you wanted to install either Spark or Hadoop, so these are the things you need to know. Any hardware, install Linux or Windows. So Windows, I don't recommend. Linux, Ubuntu operating system, Red Hat, any Linux, and you need to install Java. Why? Spark and Hadoop is created using a language called Java. Java virtual machine or Java latest software you need to install. On top of that, you have to go and use either Hadoop or Spark. Spark cannot run, cannot store the data in the hard disk. Spark is going to be storing the data into the RAM. Spark is only data processing engine, right? It can distribute the data, it can run the data parallelly. Fault tolerance means if anything is failing, it is going to be giving the data to one more node, and it is going to be 10 times faster. So this is what you need to understand. Clear? If you have a small amount of data, we are going to be using BI architecture. This is for the small amount of data. So BI architecture comes when you have data in a less amount of data or less data. So normally we're going to be using business intelligence architecture. So all the data coming from SQL, Excel, all the data will go. We are going to be creating what is also hardware with SQL. It is a staging server. It is also one more SQL or RDBMS computer. Any ETL, maybe SSIS, Informatica, all the data, completely structured data we are talking about, right? So data warehousing can get all the data with the help of ETL. We clean the data in the staging area, and the clean data with the help of ETL, we are going to be dumping into data warehousing. And here we create a data warehousing dimension tables and the factor tables. And after that, we create a reports in the visualization. So this was the when you have a lesser data. So this architecture will not work for the big data because it is all the decentralized data you're dumping into centralization, right? All the decentralized data you're dumping into centralization, it is not going to work. So in the big data environment, so if it is less data, this is the style. But big data means what normally we do, we are going to be getting maybe data coming from social media, unstructured data, maybe data coming from the files, okay, maybe data you're getting from the SQL databases. All the data you should be able to perform ELT operations, not ETL. ELT, get the data, and here I'm going to be using EDF. It is going to be bring the data, all the data, maybe files, social media data. You may be installing either Hadoop, right? If you're not Hadoop, at least you store all the data into the data lake or a blob. That is what we knew. What is a blob or data lake? Cloud folders. All the data, how do you store here? All the data will be stored in the files only. So all the data will be coming here. Now, this one, it is simply storing permanently. Storing. So after that, with this data, so much of a data I have, so I need to do cleaning work. So cleaning work purpose, we're going to be using Azure, Databricks, it is going to be taking a cluster. Multiple machines are going to be reading this data, reading all the files. Now it is going to be using a cluster. Taking all this data, distributing all the data, either it cleaned data, you are going to be loading into, this is what is called a raw folder. Clear? After that, ADB is going to be running a cluster. All the data, terabytes, petabyte of data will be cleaned by multiple machines. Cleaned data will be loaded into one more data lake or a folder. It is clean data will be coming here. Now this is cleaned. Afterwards, what normally we do? This data again, I'm going to be running one more ADB, Azure Databricks. And here also I'm going to be using same cluster. It is going to be aggregating or processing your data. So in simple terminology, I have 10 and a 20 and a 20. Now I need to clean the data, remove duplicates. I will say 10 and a 20. I have removed. Now I want to get the sum. What is the sum? 30. So you assume now data is not there in the two numbers or three numbers. It is a billions and trillions of data. One data cannot clean. One machine cannot clean. So that is the race. So ADF simply dumping all the raw data. Afterwards, the cleaning work can be happening by your cluster. What software it is going to be having? Apache Spark. Right? So ADB is a paid software. That is what I told you already. Apache Spark, ADB. What is the difference between these two? Apache Spark is completely free software. So many companies went to Apache Spark. They said, hey, Apache Spark, we wanted to buy hardware. Anyhow, you're giving software for free. We will install Apache Spark in my machines. But tomorrow, if any error comes, will you be supporting us? Apache Spark said, no, 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 no. I will give you free software. You buy hardware, you install Apache Spark. Any error comes, you don't come to us. That is what Apache Spark company said. So this is where few people from Apache Spark came out. They have created a Databricks in 2012. They said, okay, Databricks is the paid software. So what Databricks is telling you, hey, you need software, right? You don't go to Apache Spark directly. You come to us. Databricks is saying, you come to us. So what we do, you buy hardware. In your hardware, we are going to be installing Apache Spark. That is a big data software. But if there any problem comes tomorrow, we are going to be solving. Clear? The technical help Databricks company is going to be giving it to the third party companies. For example, Walmart company wanted to store their big data. So big data to store, we have Spark. So they can get the hardware, they can install Apache Spark. Tomorrow, any problem comes, Apache Spark will not give any solution. So you need to hire people, you need to troubleshoot on yourself. So instead of, some people from Apache Spark came and they created a company called Databricks. If there any problem comes, these people will know, because these Databricks people came from Apache Spark. The engine elements, the architecture about Apache Spark, everything Databricks company knows about it. Clear? So Databricks said, if you wanted to work on the big data, especially data, if you want to work on the Apache Spark, you come to Databricks. Databricks will give you same Apache software, but we will give you on top of that complete support. Plus, we will give you single platform to write your code. And we will give you, if tomorrow Apache Spark releases a patches that you need not install, we are going to be installed. Everything we are going to be maintaining for you. Databricks will said everything will be maintaining, but we are going to be giving you full support. That is what is Databricks. Clear? So Databricks, nothing but your Apache Spark company people came out in 2012. They have released. So Databricks is nothing but Apache Spark. Databricks you can run, or you can simply go and install Apache Spark in your machine. That is up to you. Clear? So landing data, all the data will come. So we're going to be creating a bronze, silver, gold. Data engineers are going to be bringing and working on this. This is a raw data, right? So after that, we create a silver and a gold. Silver data means cleaned data. will be available. So data scientists, machine learning people can get the raw data. Process data will be used by your business users like Power BI users and everything. So this was a story. So Parquet files we are going to be using, delta tables we're going to be using, delta tables we're going to be using. So what is a Parquet? What is a delta? It is inside your Databricks components. We are going to be talking about later. So lot many things we need to understand. This is what is called medallion architecture, right? What is a Parquet? What is a delta? What is a Lakehouse? We are going to be implementing later. Databricks founder is Dr. Ali Godse. Introduced this one in 2012. He came out from Spark. They have designed the Spark engine. These guys came out, started this Databricks. Now today, entire world is using a Databricks. If you wanted to use paid software, free means don't go to Databricks. You get the download the software from the Google and try to troubleshoot yourself. Clear? So we're talking about a lot of other things. We'll continue further. So today, data means structured data. It is going to be implementing in data warehouse. So AI cannot work on the structured data. AI is going to be working on the structured data, data lake or the blob. We're going to be using the files. After that, we're going to be cleaning and processing, and this data lake data will be given to AI models. So data and AI, this is what you need to understand. So if you wanted to work with the Databricks, so you should know the architecture. Data factory is going to be ingesting the data and storing in data lake or a blob. So Databricks is going to be cleaning and transforming the data. This data will go here. So from Azure Synapses, where it is your data warehouse, you can perform your Power BI and everything, or you can clean the data also. You can give it to EI people, right? BI people, Power BI can use. So Databricks data, clean the data again. It is going to be storing in somewhere here. From here, you can take and try to give it to the EI people. These are the Databricks architecture I'm talking about. Clear? Data warehouse means BI and reports. So you have structured data, ETL, data warehouse can store, BI reports can be performed. Data lake means what? You have this kind of a data we're going to be storing in the data lake or a blob. Then some data, structured data will be stored in the data lake, and unstructured data will be used by the data science and machine learning programs. On the data warehouse, always we run BI and report. Remember, so on the data warehouse, we don't run AI. Always I told you, right? So AI is not going to run on your this data. Remember, so most of the time, this clean data will be supplied to the data science and machine learning. It is unstructured data. Clear? But today, in Databricks, we are also taking a data warehousing and a data lake, combining it together. So this is a very, very big achievement. A data lake house is created. Clear? So data warehouse features, data lake features are combined today, and this is a very, very important concept I'm going to be working tomorrow in the Databricks. People will ask you, what is a data lake? Here we are going to be talking about a delta lake tables also. Delta lake tables are the new concept is implemented. Databricks unique features is one of these features, right? It is data warehouse and a data lake concept. Data lake, it is going to be having structured data, unstructured data. Unstructured data will be used by AI, structured data will be used by BA. But here you're going to be combining data lakehouse feature, data warehouse and lakehouse features, and you take a data lake today in your data, Azure Databricks. Lot of interview questions are going to come. We'll discuss about all these things in the later. And we have streaming data, batch data, lot of data. Streaming data means we'll talk about later. So Hadoop can store, can Hadoop can only process batch data. Batch data means historical data, but your Spark can store batch data and streaming data also. Clear? So graph data, pattern data, nodes, all of them are you can implement in your Databricks, but Hadoop cannot take your streaming data. Clear? So data lake, we'll talk about all of them. Transaction support, schema enforcement, all of them, you need not worry about it. We'll continue further. Databricks is a cloud-based data engineering tool that helps organizations to process, store, analyze it. It can be used for a variety of purpose: machine learning, data science purpose, business intelligence purpose, data management, security, lot many things we can do with the Databricks. Databricks is a big data software. Databricks is paid software. Databricks is going to be installing Apache Spark in your cloud machines. You may be taking the machines from Azure, then it will become Azure Databricks. If you're taking the hardware from the AWS, it will become AWS Databricks. If you're getting cloud means rental machines from the GCP, Google Cloud Platform, it will become Google Cloud Databricks. So Databricks is an independent software. This can run on Azure, then it will become Azure Databricks. It can run on your AWS. It will become AWS Databricks, and Databricks is going to be installing Apache Spark. Apache Spark is free. You need to pay the amount to Databricks people because they're going to be giving you support, and you have to make the amount to the Azure because Azure is providing you hardware. Without hardware, you cannot install any software. And tomorrow, patch upgradations and if you wanted to write the code, you need to have one UI. Everything will be given by Databricks. So Databricks is a paid software for the big data, right? If you instead of using big data, you can use BigQuery from Google or Amazon EMR. That is also one more software. Lot many softwares are available. One of the software is Databricks. Clear? So if you wanted to deal with the big data, any questions?